What is my mu?
Today in this lab, I'm going to demonstrate how, even though we can't see it, mu is used in everyday activities, without us even knowing it. Some examples would be sliding a book across a table, a baseball player sliding into home plate, or even a ball rolling on the floor. I, however, am going to show and figure out what my mu is if I run and then slide on the floor until I come to a complete stop. Let's start off with what mu is. Mu is the measure of the stickiness between two surfaces. There's a more complex definition, but we're just going to stick with this one for now. Now let's get to the fun part. First step. Execute the experiment 5 times and collect the data for each trial. Then record the data into a table and average each column. Alright, so I just completed 5 trials and wrote them down. I will show you that in a moment, but first I want to show you what I did in a picture form. I ran from here to here and then slid from here to here. I measured that in meters and will represent that as delta x. I also timed from here to here, and that will be represented in seconds. Okay, so these are all of the equations that I'm going to be using during this whole video. The one that I just got done using was this one right here. It helped me find acceleration for each trial that I used because I know delta x, which we use as distance, and time for t for time. And then for the average, we don't need to find distance or time, we just needed to find the average acceleration so that we can now plug it into this equation right here to find our F net. We just found our Fg, which equals 423.36 newtons, and we also know that Fg equals Fn because of our free body diagram, so we can plug these both in since we know that they're equal. We just found our F net, which is 154.29, and we also know that F net is equal to force of friction, which we will place right there, and that makes our free body diagram complete. Back to the beginning, what is my mu? My mu is 0.36.